So we're gonna do another problem, and these are gonna be like more like graphic problems. So yeah, it's gonna be calculus is gonna be pretty heavy, but they're still fun to do. So yeah, let's do them. So we'll now analyze some graphs where t is not independent of the variable. Consider the following sinusoidal, whatever. So the first thing we all know is that this is actually a graph of pi sine pi x. V equals sine pi x. And that's just like use that from memory, like kind of like how you can recognize like, oh, this is a cosine graph, or this is sine graph. So here I'll show you. Y equals sine pi x. Shoot, that didn't work. Anyway, you kind of see it like 0, 1, 2, 3, 4. So yeah, see, it's like the same exact graph. Just look at this same graph. So yeah, that's if you didn't get that, it's okay. You just have to recognize it. You can learn them a bit more. Second thing we need to know is that a equals dv of dx. A equals v dv dx. So we actually derived this in the last video, so you can like look at that later. Yeah, physics 6 or whatever. I forgot what I titled it actually, but yeah, it's this. And basically, what we see here is that if we take the derivative of this expression, it equals to if we take the derivative of this expression, we get this term, dv over dx, which we can plug into here and find the answer. So yeah, basically my intuition when I did this problem was like, hey, I need an expression to relate the two variables, right? So I wrote down like basically anything I could think about this graph. So the first thing that popped up to me was this sine pi of x. Second thing that popped to me is a equals vd v dv dx, and the reason why was because well I had no t value, so couldn't do dv dt. And an important thing that I need to say that I probably should say earlier is that the kinematic equations do not work here actually, because kinematic equations only work when acceleration is constant. This is not constant. It's not constant. So we have to use calculus. That's why. Um, Yeah, so this came up to me because we have v and dx, and basically all I just noticed is if I take derivative of this, then I get that. Okay, so let's actually take the derivative. What is it? Pi cosine pi of x, I think? Yeah, because what I did was I did the outer layer, which is everything. So basically everything, I guess. The outer layer times the inner layer. Derivative of the outer, so cosine pi of x. So the derivative of the outer doesn't touch the inside times the derivative of the inner, which is just pi. Yeah. So yeah, and v is given by this. That's also another thing I want to show. V is just given by this. So yeah, we get a equals to sine pi of x times pi cosine pi x. That's our final expression. And remember, it's at 0.25. Oh, a common thing I want to say, or something I want to say is hey, they could like, hey, yo, like, if we know it's at 0.25, right? Why can't we just say it's 0.5? And like, this was actually my first intuition, and I thought I got the precedent right initially. I read this book like maybe like a year ago, and then took a break from physics because I was like getting burned out. But now I'm back. But what I'm saying is like when I did this the second time around, I was like, wait, if I plug in 0.5, it's not actually the answer. So what's up? And basically, what I realized is I need the exact expression. It can't, like, it might look like it's 0.5 here, but you can't go enough just off looks. So you have to actually plug it in. Yeah. So what do we get? Sine pi of x. Pi and x is 0.25. And we know it's 0.25 because it says here. So pi over 4 times pi cosine pi over 4. And if you have taken like geometry, or I guess I did this in algebra too, um, you will know that this term, sine pi over x, and this term, they are both this. This is just a trig identity. or I guess just something to memorize. It's just like something that you learn. Kind of like how pi or sine squared plus cosine squared equals to 1. It's just something that you know and like learn. So pi times square root 2 over 2 times square root 2 over 2. So this is equal to pi. The top becomes 2 over 4. We have pi over 2. What an elegant way to end the video. Thanks.